Hi everybody. Hello. Am I audible and visible? Just a minute. Let me check it out. Yes. Okay. All right then. Very good evening, guys, and a warm welcome to Vedantu JEE English channel. This is me, your master teacher, Nabamita JEE, and today we are here. We are starting with solutions, the first chapter for class 12th. I mean, not as per NCRT, but we are starting with this chapter. Okay, yes, because this is very closely related to some basic concepts in class 11 where we learnt about molality, all of that, right? Molality we did not learn about it, but molarity, mole concept, and all of this, so these are also utilized in this chapter a little bit. So I thought, because it's such a close connection, I think we should start with this chapter, right? And if you all are thinking that, ma'am, why are you sitting and teaching today? Well, that's because my neck and my back is paining a little too much today, and I do not think I will be able to take the whole session while I'm standing, which is why I thought that I will sit and teach you today. So quickly go and call up your friends and let's start with the solutions chapter. Yes, solutions part 1. Now, why are we reading this chapter? Well, that's because, as you can see on your screen, that the last 3 years weightage kind of looks like this. Okay, last 3 years weightage, if you see, in 2020, 21% had come from this chapter. In 2022, that is last year, 33% was from this chapter. Yes, and moving on, here is also here is also a topic wise how many questions usually come. That also I have noted here. If you can see that expressing concentration of solutions, there have been in the year 2020-22, out of 22 sets, only one set had this question. Yes, colligative properties and determination of molar mass had the most number of question. If you are not able to see me, let's switch me off and now you can see, I guess. Yes, in the year 2022, out of 22 sets, 11 sets had colligative properties and determination of molar mass. So basically, actually the chapter is very easy. Okay, actually the chapter is very easy. It's not that difficult, and we also know from which topics majorly the questions come. Majorly the questions come from vapor pressure of liquids and solution. Solubility, expressing concentration of solution is very important because you need it to solve the numericals, right? To solve the numericals, you need this topic. Okay, all right. And colligative properties and determination obviously is very important because mostly the questions come from here. Apart from this, abnormal molar mass, this is also important. Okay, so these are the few topics that are really important for us, and this is where we are going to focus on. All right, yes, but obviously in today's session we are only going to cover some of the topics, not everything. So are you all ready? Can I have some la in the chat box? If you all are ready, also go and call up your friends, everybody. I don't understand why such less students are watching. I think it's a JEE, and the sooner you start with the chapters, it is better, right? So don't forget to also subscribe to the channel, because as you know that this channel not only deals with JEE but also other exams like MSET, BITSET, VIT, EEE, CUET. All of these will be catered to even more this year. And now that you already know that Pratik sir, Kiran sir, I am, so the team is complete. We are all going to take care of you. Okay, amazing. I can see that la, and somebody is also saying that Josh is high. I do not see it in the number of students though. Anyway, hi Swapna, welcome. So shall we start, everybody? Let's start. What do you all say? Let's start. By the way, today my mobile phone is below, so whenever you say something, I will be looking down because I might have to see the chat. Okay, all right, so let's begin. Yes, now the first question that comes into our mind when we talk about solution is, what really is a solution, isn't it? And if we had to define solution, do you know what we would say? Do you know what do you think? What would we say? Solution is actually a homogeneous mixture of two or more components. Okay, what is solution? Solution is a homogeneous mixture of two or more components. Okay, mixture of two or more components. Alright everybody, this is our definition of solution. Now you might ask me that ma'am, homogeneous is written here. What do we mean by homogeneous? Well, bachcha log, pasangalas, makkalas, everybody, you know that homogeneous is basically, homogeneous, as I already explained to you, it means uniform. It means throughout the solution it's going to be same. Okay, throughout the solution it's going to be same. So solution is a homogeneous mixture of two or more components, right? Now according to this picture, you can see that solution has majorly two components. One is solute, one is the solvent part. Okay, and generally we know that generally solvent is the component that is available in larger quantity. Okay, so can I write it here? Generally solvent is available in larger quantity. All right, is available in larger quantity. All right, and solute is in small quantity. Solute is available in small quantity. Is this much clear, guys? Is this much clear? Is this much clear, everybody? Yes? Everybody, Swapna, Mahashri, Tech Zone, are you all clear with this? Yes? It's Rocky, everybody clear? So solvent is available in larger quantity and solute is available in smaller quantity, right? We understand this much. Great. Now, in general, everybody, right? In general, video is not clear. Bacha, if video is not clear, what you need to do is right at the top of the video, at the right hand side corner, there is a, there is a setting sign. So what you need to do is just click on that and change the quality. That way you will be able to see me better. All right. Yes, see, I have just changed and now I can see myself clearly, absolutely clearly, everybody. Swapna, the video is clear as I can see. All right. Okay. So solute is available in small quantity and solvent is generally available in large quantity. Is this much understood, everybody? Is this much understood to everyone? Yes. Now you might think, normally what we know is that if you add salt into water, it's a salt solution. If you add sugar into water, it will become sugar solution. But do you think that always there will only be two components in a solution? Actually, no. That's not right, because guess what? A solution can also be binary, it can be ternary, and it can be quaternary. So if it is binary, there will be one solute and there will be one solvent. Yes. But if it is ternary, then there are possibilities that there are more number of solute. For example, lemonade, when you mix sugar, salt, lemon juice into water, then it is a quaternary solution. Are you getting my point? Yes, are you getting my point? That solution is a homogeneous mixture of two or more components, and generally solvent is the one that is available in larger quantity, whereas the solute is available in small quantity, right? And we know that a solution can also be binary, ternary and quaternary. Now, tell me something, that whenever we say solution, in our mind, we always think that a solution has to be liquid. Solution has to be liquid. What if I tell you that actually no, There is also a possibility of a solid in solid solution, a possibility of liquid in liquid solution, a possibility of gas in gas solution. What will you do? Are you going to tell me that, no, ma'am, you think you have gone crazy and that's not possible? But I'm telling you that it is possible. So what then? So who decides this state? Who decides that the solution is going to be solid, or is it going to be liquid, or is it going to be gaseous? Who decides it? Do you know who decides it? Is the solvent. Okay. Who decides it? The solvent decides. Okay. Solvent decides the state of the solution. All right, everyone. Is this clear? Is this clear to everyone? Okay, there is a doubt, I see. So what will be considered as solvent and solute when more than two solutions are mixed in equal proportion? That doesn't happen. Normally, skull breaker, we usually see that the solvent is the one that is generally present in the larger amount. And most of the time, you will see that one of them will be available in larger amount. Okay, and that will be considered as a solvent. Got it? Yes. Yes, skull breaker, smoke, solution of solvent as gas and solute as dust particles. Absolutely right. Yes. If quantity is not given, then how to decide solvent and solute? Anushka, that we will come to that later. Okay, we will come to that later. Don't worry about it. We will come to that later. Okay. But till now, is everything clear? Till now everything is clear? What is a solution? Solution is a homogeneous mixture of two or more components. What is homogeneous? Homogeneous means uniform. Homogeneous means uniform, and generally solvent is available in larger quantity and solute is available in smaller quantity, right? Then I told you that a solution can be binary, it can be ternary, it can be quaternary, and who decides the state of the solution? It is usually decided by solvent. Solvent decides the state of the solution. This is clear, right? So here are all the examples, my dear students. Just take a look at it. There are gaseous solutions possible, yes, where the solute is gas and the solvent is also gas. If it is a gas in gas, then what is the example? Example is mixture of oxygen and nitrogen gases. Air. Air. What happens in air? In air, you have nitrogen as well as oxygen, isn't it? So that is a gas in gas kind of solution. Make sense? Make sense? Nonsense, everyone? Makes sense, right? Okay. Now, what if I say that liquid is the solute and gas is the solvent? Have you seen somebody kidnapping someone? In the movies and everything, you must have seen, right? How they put some chloroform and the person becomes unconscious. Yes. So, chloroform that is mixed with nitrogen gas is a common example of liquid in gas. Chloroform is liquid, it is solvent is nitrogen gas. Yeah, that doesn't mean that now you know how to mix it, you will go and kidnap someone. Yeah, promise me no one is going to kidnap anyone. Just kidding. I know you are all good child and you will not be doing it. Anyway, now what if the solute is the solid and the solvent is gas? What then? Camphor in nitrogen gas. Camphor in nitrogen gas is also a possibility. Okay. All right. Yes. Now let's come to liquid. Okay. I will have to, take myself off the camera now. So so that the whole screen is visible. Now, if the solute is gas and the liquid is solvent, then, hey, everybody knows that aquatic life, fishes, plants, which are all aquatic, how do they survive? They survive because they breathe in the oxygen that is dissolved in water. Am I right, everyone? Then if liquid is dissolved in liquid, then what is it? Alcohol. How many of you have already started to do it? Brinda Bacha, this is a video for JEE 2024. I'm so sorry that it is not written in the thumbnail, but this is a video for JEE 2024. Bacha log, I have started with JEE 2024. Okay. So liquid in liquid. How many of you have already started drinking? Please say no. Please say no. I hope you are not drinking. But if you have seen someone, those people who drink alcohol, right? What happens there? They mix alcohol into water. And what happens? Alcohol dissolves, right? Alcohol dissolves. So ethanol dissolved in water is actually an example of liquid in liquid. Then when solid dissolves in solvent, see, glucose dissolved in water. If you're feeling low in energy, don't you drink a little bit of glucose? Yes, absolutely. So glucose in water is basically a solid in liquid. Now we come to solid solution. See, I told you, don't be like all surprised and astonished that solid solutions don't occur, but they do. When the solute is gas and the solvent is liquid, solution of hydrogen in palladium, that's an example. Solution of hydrogen in palladium is an example. Liquid in solid, okay, amalgam of mercury with sodium. So whenever this word amalgam is there, please understand that it means that mercury is also definitely there, okay, mercury is also definitely there. Then solid and solid is copper dissolved in gold. Many a times people do wear gold plated something, right? Or because gold actually is very, very, very malleable, right, everybody? Gold is a very, very, very malleable and it's a very delicate kind of a metal, okay? So if you just make jewelries with gold, trust me, your jewelry won't even last for, a week. So that is why to harden this jewelries, you will have to add a little bit of other metal like copper, right? People do use copper, or sometimes they use silver and all of these. So copper dissolved in gold is used to make jewelries as well. Is this understood, everybody? Yes, Srinivas, you will be getting the notes after the session, okay? I will be providing it to you, don't worry. Yeah, is this much clear, guys? Now. So all of these we have understood. Acha, now we come to another topic called expressing concentration of solution. And let's understand that why is this important. Tell me something. What if I have a liquid, I have a glass container here. Okay, I have a glass container here. And I have another glass container here. Let's imagine that both of them are absolutely similar. Okay, let's imagine that both of them are absolutely similar. Here you have some water in it. Okay, and here also you have some water in it. Equal amount, right? But in the first glass, let's just say that I have added 1 spoon of salt. 1 spoon salt has been added here. And in this case, let's say that 30 spoons of salt I have added. Yes. Now, can I not say that both of them are salt solution? Am I right? Both of them are salt solution, right? Both are salt solution, isn't it, everybody? Both of them are salt solution. So what's the difference then? What is the difference, guys? The difference is the fact that in the A container, there is only 1 spoon of salt, whereas in the B container, there are 30 spoons of salt. Now, I can also use the term that this is dilute and this is concentrated, right? But even then, we know that in science, we deal with accuracy and precision, right? In science, we always deal with accuracy and precision. So do you think that just by using the word dilute and concentrated, I am sorted enough? Do you think that I'm sorted enough? No, I'm not. Because this is very vague. This talks in a very broad spectrum. It does not even give away anything. It doesn't talk about any quantity. Right? Is it talking about any quantity here? No, not at all. 30 spoons of salt in science is not really a quantity. Correct? Yes, everybody? Right? So this is exactly what I'm talking. That means that we need to start expressing concentration of solutions. Yes, we need to start expressing concentration of solutions. And when we talk about quantitative concentration, we want quantity, guys. We want quantity because, hey, we are in the field of science, isn't it? So let's talk about it then. Quantitative concentration. All right. Quantitative concentration, there are actually 7 terms that we have to talk about. Okay, what are there? There are actually 7 different terms that we have to talk about. What are these terms? Number 1 we are going to talk about is mass percentage. Number 1 we are going to talk about is mass percentage. Number 2, my dear student, is going to be mass by volume percentage. Am I right? Yes? Make sense or nonsense, everyone? Number 3, my dear student, is volume percentage. Volume percentage, all right? Number 4, my dear student, is parts per million. What is it? Parts per million. Number 5 is, everybody, mole fraction, that you already know, right? Mole fraction everybody knows. Number 6 is molarity. And number 1, 2, 3, 4, 5, 6, yes. Number 7 is molality. And then there is also one more that I would like to definitely teach you is number 8. Let's write strength. Strength. This is something that I will definitely teach you, because there have been times when from here the questions have come in JEE. So we are not going to skip it. Since we are starting from basic, and this year I am going to be there with you, I think it's my duty to start from the basic, very basic, and not let go of any topic, right? Yes, so shall we start with mass percentage? What is mass percentage? Does anybody know what mass percentage is, everybody? Anyone, guys? I'm looking at the chat now. Please tell me, what do you understand by mass percentage, everybody? What do you all understand by mass percentage? Come on. Till then, I'm also going to drink a little bit of water. Tell me, does anybody know? All right, okay. So mass percentage basically means that we're talking about mass, but in terms of percentage. Yeah, what is it? Mass percentage is basically, we're talking about mass, right? Yeah, we are definitely talking about mass, but we are also talking about it in terms of percentage. So my dear students, now that we come to the definition part, what do we write? Percentage. I like it. It's like, ma'am, where do you stay? I'll be like, near office. So ma'am, where is office? Near my house. Nitin, you are writing the answer like that, huh? Chalo, koi baat nahi. Anyway, no worries. Let's write the definition, guys. Okay, let's write the definition. Awesome. Now everybody is writing it down. Now everyone is writing it down. So what is the definition of it? The definition is basically amount of solute. Okay, amount of solute in grams. Are you guys understanding? Normality, no. Normality is not expressing concentration of solution. We will read about normality in some time, though. Yes, in maybe in the upcoming following sessions we will read about normality. But it's not considered in expressing concentration of solution. At least it's definitely not there in your NCERT. So amount of solute in grams present in 100 gram of solution. Is it visible to you all, everybody? Amount of solute in grams, amount of solute in grams present in 100 gram of solution. Okay? Yes. Now let's talk about the formula. Yes. Now let's talk about the formula. What is the formula? What is the formula, everybody? The formula is mass of solute, obviously. Mass of solute divided by, what do we write? Divided by total mass of solution. Total mass of solution. Now that we are talking about percentage, obviously we will multiply it with 100. Right? Make sense, nonsense, everyone? Make sense, nonsense? Yes? Very good. Now, many a times, how would you understand that, how would you understand that we're talking about mass percentage? So, there is a symbol, obviously, right? What is the symbol? The symbol is, see, both of them are talking about mass by mass. So, can I just write W by W? That is the symbol. Now, do you remember that just some time back we also spoke about binary, ternary, and quaternary kind of solution? So, what if there is more number of solute? What if there are more number of components? What can we do? Well, in that case, let's just say that there is a component called A. Okay, let's just say that there is a component called A. In that case, hi Sai, hello. Mass percentage of, let's say, A. How can I write it? I will write it as W of A divided by WA plus WB plus, let's say, WC. There are three components. Let's say it's a ternary kind of solution. So WA divided by WA plus WB plus WC into 100. This can be my formula, right? Can this be my formula, guys? It can be, isn't it? It can be, right? Does this make sense to everyone? Does it make sense? Is this clear? This is clear to you all? Yes or no? Yes, amazing. All right. So shall we move ahead then? Mass percentage is done. Can we go to mass by volume percentage then? Can we go to mass by volume percentage? Yes. Yeah, sure, Rohan. We will do that. I will give you tips for fast calculation. In fact, you know what? I'll make a separate video for that so that, it doesn't get lost in between the academic sessions, right? I'll make a separate video about it. Okay. Chalo. Now let's understand mass by volume percentage. So what is mass by volume percentage? Same, Baba. But this time we are only doing the solution. Remember, here we took mass of solution. Now we will take volume of solution. That's it. Now we will take volume of solution. So that means that what can I write the definition as? Wait a second. Let me change the color of this thing. So let's write the definition here. What is going to be the definition, my dear student? Shankar says yes, ma'am. FF Gamer says la. Amazing. Thank you. What is the definition? The definition is amount of solute. Amount of solute in grams, dissolved in, last time we took 100 gram. Are we going to still take 100 gram? No, dissolved in 100 ml of the solution, right? That's going to be our definition. Yes, everybody? Makes sense? Great. Now, if I have to write the formula, what is the formula? What is the formula? The formula is, how to remember? You have to practice, bacha. You have to keep practicing. You have to keep practicing, okay? That's how. So, what is the formula, guys? The formula will be obviously mass of solute divided by total volume of solution. Total volume of solution in milliliter multiplied with 100. Makes sense, nonsense? Makes sense, everybody? Yes? Now tell me, what is the symbol here? What is going to be the symbol this time? This time the symbol is going to be W by V, isn't it? W by V. Now can I tell you something? Can I tell you a very interesting fact, everybody? Are you all here with me? Are you all here with me? I want to tell you a very, very, very interesting fact. And the fact is, everybody, make a note. The fact is that, do you know that mass by volume percentage actually changes with change in temperature? It changes with change in temperature. Why so? Why so? Easy peasy biryani tasty, baba, there is volume, na? Yes. So if you heat water, if you take some water and if you start heating it, don't you think that the volume will expand? Volume does change with change in temperature, and hence what will happen? It does change with change in temperature. It expands. When you heat something, what happens? It expands. You cool it down, what happens? It contracts. So my dear student, does it make sense now that it changes with change in temperature? Yes. And do you know that this W by V, or this mass by volume percentage, it is used in the pharmaceutical industries a lot. In the pharmaceutical industry, it is used a lot, like lot, okay? All right, most of the time you will find that this is being used. Okay, this is being used. All right, everybody, makes sense? Are we clear with mass by volume percentage now, everyone? Are we clear with mass by volume percentage? Yes or no, everyone? Yes or no? Hi, Jeffin. Welcome, welcome, everybody. Yes, are we clear or not? Yes or no? Yes or no? Yes or no? Mass and weight are named. No. Tech 1 zone. In the first session of class 11th, I taught you very clearly that mass and weight are not same. Mass is the amount of matter that is present in a substance, whereas weight is a force. It is mass multiplied with gravity. Okay, so mass and weight are technically not same. However, you will find many grown-up students, everybody, swapping these two terms, but that's not right. Okay, chalo then, moving on, let's understand what is volume percentage. All right, let's understand what is volume percentage. Okay, not able to place my mobile phone anywhere, just a second. Yeah, I think this will do. So what is volume percentage? Now that we come to volume percentage, first let's write the definition. What do you all say? Let's write the definition. Same, everybody. Same, but what do we write this time? Okay, what do we write this time? This time we write that volume of solute in milliliter, yes, dissolved in 100 ml of the solution. Got it? Yes. Abhay Rai, do you think that I'm just passing my time? Do you think that I have a lot of time in my hand? Huh? Do you really think so? Why would I tell you something that is not useful, Baba? This is very useful for your JEE. So please make sure that you are focusing here. Okay. So volume of solute in milliliter dissolved in 100 ml of the solution is the definition. Okay. Now we come to the formula. What is the formula here? The formula here is obviously volume of solute divided by total volume of solution. Right, but it is again percentage, so we have to write multiplied with 100. Did I write it in the last one? I have. Great. Okay, so this is the one, right? Now obviously we will also write the symbol. What is going to be the symbol here, everyone? What is going to be the symbol? The symbol is obviously V by V. Now tell me, do you think that this will also change with change in temperature? Absolutely yes. We are still talking about volume, guys. So yes, it changes with change in temperature. Basically, one trick that you have to remember is wherever volume is involved, just write down that it changes with temperature. Okay, it changes with temperature. Acha, now tell me, what if I say that, let's take an example just to make you understand this better. Okay, volume percentage. What if I say that 20% alcohol solution? What do I mean by this? By 20% alcohol, my dear student, I mean to say that 20 ml of alcohol, okay, 20 ml of alcohol is dissolved in water, resulting in 100 ml of solution. Are you getting my point? What I mean to say is 20 ml of alcohol is dissolved in water. Yes, Satyavati, I will. Wait. 20 ml of alcohol is dissolved in water such that resultant is 100 ml solution. So that means if I say 20% alcohol, that means 20 ml of alcohol and 80 ml of water together will make 100 ml solution, right? So once again, if we have to explain volume percentage, it means that we are talking about volume and volume, but in terms of percentage. So volume of solute in milliliter we will take. Then we will take divided by total volume of the solution and multiply it with 100. Yes, that's the formula. Symbol is V by V. It changes with change in temperature, obviously, because it is talking about volume, right? Yes, everybody. So is this clear now? Is this clear, guys? Is this clear? Is this clear? Come on, tell me. Shall we move forward? Shall we move forward, guys? Acha, is my voice audible and visible, everyone? Are you all able to see me and hear me clearly? Yes, is this clear? Chalo, in that case, now let's go to parts per million. What is parts per million? When do we talk about parts per million? Whenever there are very trace amount of substances are present, okay? Whenever there are trace amount, that is very small quantity is present. Trace amount of substance is present. Whenever there is trace amount of substance is present, okay, that's when we talk about parts per million. So what is the definition going to be then? What is the definition going to be, guys? The definition, my dear student, is going to be, let's write it down here. What is the definition? Can anybody tell me? It is number of parts, yes, of solute present in million, 10 to the power 6, okay, million parts in a solution. Getting my point, everybody? Yes. So what is the definition? What is the formula then? This time, what is going to be the formula, everybody? This time the formula is going to be number of parts of solute divided by total number of parts of all components of solution. Parts of all components of solution. Now this time, am I going to multiply it with 100? No. This time we will multiply it with 10 to the power 6 because million. Hey, we're talking about million. So what is the symbol here? What is the symbol that we use? The symbol that we use is ppm, parts per million. Acha, where is it used? Do you know where is it used? When we are talking about the pollutants present in the atmosphere. You understand that atmosphere is huge, isn't it? The number of air molecules or the number or the amount of air as a solution, it is huge, right? But in that, the pollutants that are present is in trace amounts, very little amount. So at that point of time, we talk about it in ppm. Apart from that, another example. Let's say that you have a well. Kuan samajhte ho? Well. Yes. So if you have a well and you want to purify the water that is present in well, what will you do? You will only take a pinch of potassium permanganate and you will put it in the well, and that the amount of potassium permanganate that is present in the well is what? Parts per million. The amount of water that you have is huge, but in that you are only taking a pinch of potassium permanganate. Are you understanding my point, guys? Are you understanding my point, everybody? Yes, Sapna, we will be able to, bacha, don't worry about it. Yes. Don't worry about it. Yes. Ramesh, I'm very sorry, but I do not know how to speak in Telugu, bacha. I'm so sorry. I can only speak in English, Hindi, Bengali and Assamese and not Telugu. Extremely sorry, okay? Yeah? Is this clear? Is this clear, everybody? Please let me know if it is clear. Shall we move ahead? Shall we move ahead? Yes or no? No one is. I'm looking at the chat box, but I guess everyone is sleeping. Yo, wake up. Vanakam. That I can say. Acha, hi means Nanu Deguntara. Okay, Ramesh. Thank you so much for teaching me something new. Okay, guys, are we clear or not? Yes or no? No one is telling me anything. Okay, I think let's move towards mole fraction now. Let's move towards mole fraction, everybody. Yeah? Chalo. So what's the definition of mole fraction then? Not clear. Or clear? Tech 1 zone, what are you saying? Acha, hi means namaskaram. Ma'am, why like this? Why not in board? Tamil IIT, and basically I'm having a really bad neck and back pain. I don't think I will be able to take the session standing for, 1 whole hour. I'm not able to, I'm not able to even like stand for 5-10 minutes properly. It's paining a lot. And that is why I thought I did not want to cancel the class. And that is why I am taking the session like this. I hope you will forgive me for this. Tomorrow, if I feel fine, I'll definitely take the session normally. Okay? Yeah? Alright. Thank you, Swapna. Thank you. So, let's talk about mole fraction, everybody. So, what is the definition of mole fraction? What is the definition of mole fraction, guys? Definition. Okay. Alright. Thank you, FF Gamer. I will not follow it. Acha, definition of mole fraction. Basically, it is ratio of number of moles. Now we are talking about, see, mole fraction, right? Fraction. What is fraction? Fraction means ratio only, no? So ratio of number of moles of one component. Number of moles of one component, yeah, to the total number of moles of all components, right? All right, guys, that is the definition. Now obviously we are not going to stop here. Let's write the formula. What is the formula? What is the formula, guys? The formula, I can directly write it as C. What can I write? The formula is number of moles of one component divided by total number of moles of all components. Now in this case, you don't have to multiply it with anything, you don't have to divide it with anything. That's it. That is your formula. But let me give you another example so that you are able to reproduce it in exam. So how do you write number of moles, and what is mole, guys? How do you symbolize mole? The symbol of mole is, everybody, it's like a small letter X, but how is it pronounced? It's pronounced as chi. Okay, how do you pronounce it? Pronounce it as chi. Okay, so that is the symbol. Now how do you write the formula? For example, let's say that there are two components, A and B. How am I going to write the formula? The formula will be N of A, that is number of moles of A, divided by number of moles of A plus number of moles of B. This is going to be my formula for mole fraction. Formula for mole fraction will be this, okay, during the numericals. Acha, can I tell you something important? So mole fraction of chi of A basically is this. So if I again find out chi of B, do you know that all the mole fraction, if you find out of one particular solution, it should be equal to 1. Chi of A plus chi of B should be equal to 1 because it is a mole fraction. Mole fraction, right? What happens when you add the fractions? You usually get the number 1, and that is exactly what you will get here. So is this clear, everybody? This was also easy peasy biryani tasty. Yes, now you will have to remember it. Today, in fact, whatever, all the things that I am teaching you, I will give it to you in the PDF format in the Telegram channel. But I request you all that please write down all the formula and stick it right in front of your study table, so that you can go through it again and again and you can remember all of these for your problem solving. Moving on, let's talk about molarity. Okay, so of course we will write down the definition first. What is the definition of molarity? I hope everybody knows it and remembers it from class 11. What is the definition of molarity, guys? Tell me. What is it? Number of moles of solute, number of moles of solute dissolved in, this time when we talk about molarity, we talk about moles of solute that is dissolved in volume. Okay, so that is moles is related to volume in this expression of concentration. Getting my point, everybody? So number of moles of solute dissolved in 1 liter, dissolved in 1 liter, or you can also write it as 1 dm cube, 1 dm cube, okay, of solution, of solution. That's your definition, that's your definition, everybody. Cool. So now that we are done with this, let's also write down the formula. What is going to be the formula, everyone? The formula is going to be moles of solute as it is written in the definition. Moles of solute divided by what? Divided by volume of solution in liter or in dm cube. You can use any of this, okay? You can use any of this, and that's it. What is the symbol? Guys, whenever we talk about molarity, remember that it is always denoted with capital M. Now tell me, will it change with temperature? Of course, absolutely it will change with temperature, because once again we have volume here. So it changes with change in temperature. Changes with change in temperature. I'm sorry. Changes with change in temperature. Absolutely it does. Okay, absolutely it does. Getting my point? Yes. If molarity is done, now finally let's talk about molality. Guys, please don't get confused. Molarity and molality are different. Molarity is MOLARITY. Molality has MOLALITY. These two things are different. Many students do get confused, but are you going to get confused? No, I have told you right now, molarity and molality are different. Okay, so now what is the what Toma has understood, Satyam has understood. I hope everybody has understood, guys. Yes. When volume was there, then it will change the temperature. Yes, Tech 1 zone. Whenever there is volume, as you know, when you increase the volume, what happens? When you increase the temperature, the volume expands, right? The volume expands. When you decrease the temperature, the volume contracts. Yes. So that is why you will see that with temperature, there will be a change. Okay. With temperature, there will be a change. Now, molality, everybody, what is the definition of molality? What is the definition of molality, guys? What is the definition of molality? This time also we will talk about number of moles. Number of moles of solute in what? In per kg of solvent. Yes, per kg of solvent. That's what we talk about. Okay. So that means what is the formula? The formula is going to be mass of solute divided by mass of solvent in kg. Mass of solvent in kg. That's the answer. What is the symbol? The symbol, my dear student, is small m. And that is also another difference, guys. Molarity is denoted with capital M, whereas molality is denoted with small letter m. Am I clear, everybody, with all of these? All of these, are we clear? All of these, everybody, are we clear? Did we understand everything that I have till now taught you? Did we understand everything that I have till now taught you? Guys, please let me know. La la la. Do we have a la la la? Yes. Or EPBT, easy peasy biryani tasty? Amazing. All right. So now let's do the final one, that is strength. Okay, that is strength. So let me write the symbol here. What is the symbol of the strength? Symbol of strength is gram per liter or gram per dm cube. That's the symbol. Okay, that is the symbol. Anushka, we are not talking about normality when we are talking about expressing concentration of solution, but you will learn about normality very soon. Don't worry about it, okay? Right now, we are focusing on expressing concentration of solutions, and according to this, there are 7 terms. Strength is also another 8 term that I'm teaching you here because there have been some or the other numericals that are related to strength, okay? Yes. Now, coming to the definition, guys. What is the definition here? What is the definition of strength? You are going to be like, ma'am, biceps and triceps, ma'am, bodybuilding, that's strength. No. Definition is amount of solute. Amount of solute in grams present in what? Present in 1 liter, obviously. Present in 1 liter of solution or solvent? 1 liter of solution, guys. 1 liter of solution. So take a look at it. Strength is very much equal to, is very much like molality. However, molality talks about mass of solvent in kg. But here we talk about 1 liter of solution. We talk about basically volume. Strength is basically mass by volume. Mass by volume is only strength, okay? Mass by volume is only strength. So let's write down the formula then. Let's write down the formula. What is the formula, everybody? What is the formula, guys? The formula is mass of solute in grams divided by volume of solution in liter or dm cube. That's your definition for strength. Is this clear, everybody? Now tell me if this is clear to you all. Are we ready to do a problem? Are we ready to solve a problem here, guys? Come on, everybody. I need answers now. Yes, Anushka, are you clear with it? Yes, Mahashri, are we clear with it? Swapna, everybody, are we all clear with it? Yes? Yes? In fact, normality also I will teach you, but not right now, okay? Let's build up our basics first and then we will go to normality. We will do normality, I promise, yes. I promise we will do normality. It does come under expressing concentration of solution only, but the point is that I want to start from basics. So right now, let's talk about all of these, okay? Alright? Okay, Rupesh. Alright, bacha. Thank you so much. Now, moving on from here, I have a question for you. So tell me. The molality of a urea solution in which 0.0100 gram of urea and NH2CO is added to 0.3000 dm cube of water at STP is. We have to find the molality, everyone. Okay, what do we have to find out? We have to find the molality. So that means M is equal to, what is molality, guys? Molality is basically moles of solute, right? Moles of solute divided by moles of solvent in kg. Moles of solvent in kg. Am I right? Is that the thing? Right? Now, how do we find out moles of the solute? Are we given moles of solute? No, we are not given moles of solute. But if you remember, in class 11, you have learned moles of solute. How do you calculate moles of solute, Baba? Yes? You calculate it as mass in grams that is given to you, and you divide it by molar mass. Now, mass that is given to you is, as you can see, 0.0100 gram. 0.01, isn't it? 0.01. I can write it as 0.01 gram. Molar mass of urea, everybody just write it down that molar mass of urea is 60. Okay. What is the molar mass of urea? 60, everyone. So 0.01 divided by 60. That is going to be my moles of solute. So now if I still have to calculate, I can calculate as a molality. For molality, I can calculate it as 0.01 divided by 60 divided by moles of solvent in kg. See, 1 kg is equal to 1 dm cube is equal to 1 dm cube is equal to 1 kg, as we know. So 0.3. I have to directly divide it by 0.300000. Yes. Now what is going to be the answer? Calculate and tell me what is going to be the answer. Shall I use my calculator? Let me use my calculator here. It is 0.01 divided by 60. There is equal to this divided by 0.3000. It is 0.00555. So I can also write it as 5.55 into 10 to the power minus 4, because 1, 2, 3, 4 minus 4 mole per kg. Am I right, guys? Can I write it like this? Yes, can I write it like this? That means that option B is the correct answer. Right, everybody? Yes, very good, Swapna. Very good, very good, very good. Is this clear, guys? Is this clear? Chalo, next question, everyone. Next question, please read it, please read it. A 6.50 molar solution of KOH. Not understood. Tech 1 zone. Acha, Rupesh, what is it that you did not understand, bacha? See, in the question, it has asked the molality of urea solution in which 0.0100 gram of urea. So, you are given the mass of solute. Mass of solute is given to you. Okay. Yes, this is urea. This is urea. It is added to 0.3000 dm cube. Now we know that 1 dm cube is equal to 1 kg of water at STP, right? So, see, a significant figure, do you remember from class 11 some basic concept of chemistry? Significant figure. Significant figure. Do you remember? Tech 1 zone. Significant figures. So, acha, chalo. So basically it's that only, no? Acha. Tell me something. 0.1 is equal to what? What is 0.1? 0.1 means 1 by 10. 1 by 10 means what? 10 to the power minus 1, right? Yes. Now if I write 0.001, that means what? It means that 1 divided by 1000. Yes, that means that how can I write it? 10 to the power minus 3. Can I write it like this? Yes, bacha. So exactly that's what I wrote, 0.0005. So now what I wrote is 10 to the power minus 4 mole per kg, because this is mole and this is kg. That's it. Understood? 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 Okay. Next question then. A 6.50 molar solution of KOH aqueous has a density of 1.89 gram per centimeter cube. Okay. The molarity of the solution is how much mole dm cube? The molarity. You have to find out this time the molarity. Now atomic mass of K is given 39, 16 and hydrogen is also given to you. Chalo, let's solve it, everyone. Okay, let's solve it. What do we need? Acha, so molar solution is given. Molar solution is given. So let's use this formula. Small m is equal to 1000 into capital M. Okay, divided by 1000 into density. Okay, density is given to us, minus capital M, that is molarity, into multiplied with m of solute. Okay, yes, that's how we can calculate. Now let me write down all the terms for you as well. What are all the terms? M is definitely the molality. And how much is the molality given to you? The molality is given to you given to us as 6.50. 6.50. Okay. Now what is capital M, guys? Capital M is your molarity. Molarity of the solution. Do we know this? We do not know this. We have to find it out. This we have to find it out. Okay. Alright, bacha. Everybody understanding? Yes. Then what is D? D is already given to us. It is density, right? It is density, and how much is the density? It is 1.89 gram per centimeter cube. 1.89 gram per centimeter cube, right? Finally, molarity of the solute is something that we can find out. What is solute here? Solute is KOH. See, solute is KOH. Yes, alright everyone. Nitin, first step you did not understand. This is a formula. This is a formula that you can use, okay? Alright. So what is M of solute? It is the, molar mass of solute. Molar mass of solute. How do we find it out? What is the solute? KOH. So let's do it then. 39 is given to us plus 16 plus 1 is equal to what? 56 unified mass. Right? Am I right? Am I right everyone? Tell me, make sense, nonsense? Now, let's put all the figures here, okay? Let's put all the numbers here. 6.50 is equal to 1000 into M. We do not know what is capital M. But 1000 multiplied with 1.89 we definitely know. Minus M we still do not know. But molar mass of solute is something that we already know, that is 56. Alright? Right? Do we know this? Yes, we know this. Acha. Now let's do this. This 1890 it will be, right? 1890. So 6.50 is equal to 1000 M divided by 1890 minus M 56. Correct? So 1890, if I bring it here, then it will be 12,000. Can somebody calculate and tell me this? Can somebody? Chalo, let me only calculate, guys. Let me only calculate. It is 12,285. 12,285 minus, okay, 6.50 into 364. 364 M is equal to 1000 M. Alright? Yes, everyone? Making sense, nonsense? Make sense, nonsense, everybody? You guys are getting it or not? Acha, now what we will do is 1000 can be shifted here or 364 can be shifted here. So it's basically 1364 M is equal to 12,285. That means molar M is equal to 12,285 divided by 1364. This will be equal to, chalo, let me do it. This is equal to 9. I don't think you are able to see it. Can you see it? Huh. This is equal to 9.00 mole dm to the power minus 3. This is your answer, guys. This is your answer. So I think option B. Option B is the correct answer. Okay? Option B is the correct answer. Got it? Clear? Clear? See, we got 9.00 mole dm to the power minus 3. Clear hai? Clear hai? I shifted and I showed it to you. Guys, is it la la la? Once again, Roshan. Please, forward it and watch it, no? Chalo, move on. I still have to teach you a lot more things, huh? Now we come to solubility. So all of these are done. Okay, all of these are done. Now we come to solubility. Guys, please ask your friends to be here. Now we are reaching Henry's law. That's very, very, very important. Okay, Henry's law does have a lot of question in your JEE, in your boards, in many calculations. Wherever you go, you will be seeing Henry's law. Anyway, now let's talk about solubility. What is solubility? Solubility is basically the maximum amount of solute that can dissolve in a given amount of solvent. For example, let's say that if I have this cup, right, and if I have filled water here, then if I put 1 spoon of salt, it will get dissolved. If I put second spoon, it will still get dissolved. Third spoon, it will still get dissolved. Fourth spoon, now it might not get dissolved. So the amount of solute, how much is the amount of solute that can dissolve? 3 spoons. So what is the solubility of this cup of water? The solubility is 3 spoon. Solubility of the solute here was 3 spoon, right? So basically how we write it as the maximum amount of a substance that can be dissolved in 100 grams of water at a given temperature. The temperature right now has to be fixed. That is called as solubility in water. Right? Yes, up to how much time? I think Rupesh, another half an hour or so, we will be able to finish it. Yeah? Alright, so the maximum amount of substance that can be dissolved in 100 grams of water at a given temperature is called its solubility in water. Now, solubility, you remember how we read about solutions. The solutions are also present solid in a liquid and gas in a liquid and solid in a liquid and liquid in a liquid. So, obviously, we will have to read about solubility of a solid in a liquid. Now, how many of you know what is this saturated, unsaturated and supersaturated solution? Let me tell you a story. Do you all know that I love biryani, and that is why the catchphrase easy peasy biryani is tasty and we do not say lemon squeezy? That's because Nabamita Ma'am, Nobita Ma'am loves biryani. I can eat biryani any time of the day, any season, morning, night, 3 o'clock also at night. If you call me, wake me up and tell me that Nabamita biryani khaogi, I'll be like, yes. So that's the amount I love biryani, right? Yeah, Swapna knows already. Amazing. Now tell me something that now that I am talking about biryani, plus it's my dinner time already, yeah? I'm very hungry right now. What am I? Did I eat any biryani? No. But do you think that I can eat one full bowl of biryani? Yes, I can. I am thinking that I can, right? So right at this point, when the fact that my stomach can take a lot of biryani, what am I? Unsaturated, because I can gulp it down. Yeah? Because I can gulp it down, I am unsaturated. I'm not satisfied. I'm hungry. I can eat a lot of biryani, right? Right, everybody? Guys, please focus up and please interact. Say yes or no so that I understand that you guys are understanding. Otherwise, I will not be able to understand. So, please say yes or no. Yeah? So, unsaturated, that means that right now I can eat a lot of biryani. If you tell me and if you take me to eat some biryani, right, I will like, what do you say? In Hindi, you say, no, pel dungi main. I can just eat, right? Okay, great. Now, what happens is, now I have had, let's say, I have had 20 spoons of biryani. Okay, I have had 20 spoons of biryani. And when I had 20 spoons of biryani, na baba, what happened was, I feel like my hunger is gone. So basically, I'm satisfied. Yeah, I feel like my hunger is gone and I'm a little satisfied. But what am I? I'm a human being, and human beings are what? Greedy. So it's like Alpenliebe, you know, what did Alpenliebe say? Ji lalchaye raha na jaye, right? So my stomach says that, hey, you are filled. Don't eat anymore. But my eyes are like, ooh, biryani. Right? I'm slurping. So what do? I feel like, no, my pants are a little tight right now. So what I do is I jump a little, right? I do like 5 or 2 jumps, and I'm like, I make my pants a little loose and I eat a little more because I want to expand my stomach. My stomach is expanding. Yeah, my stomach expands, right? When it comes to biryani, your stomach can expand, truly. And even after that, let's say that I have eaten 10 more spoons of biryani, then what happens? All the biryani is up to here. Now the biryani is still here. Now one more spoon, what will happen? I will get disrupted. I am already at the verge of puking. I'm like, wow, I can't eat anymore, right? One more spoon and I can puke. I am unstable right now. I am absolutely unstable. You can see it that I can't move from my seat. I am sitting like this. I am dazed and I am confused. Doesn't it happen when you go to a wedding function and people give you a lot of food? Does this not happen to you? It happens, right? And exactly that's the story of solution, my dear student. So in an unsaturated solution, the solution still has the capacity to take in more solute. It can take in more solute, and that's when it is not satisfied, we call it as unsaturated. Yeah? Now when you have added 3 spoons of salt and the solution is like, bus, I can't take anymore, yeah, that's it. That's when saturated. The solution is satisfied now, okay? The solution is satisfied, so it is saturated. But human being tendency, we were like, no, expand, no, we want to put in more salt. So what did we do? We increased the temperature. We boiled the water. We increase the temperature, right? When we increase the temperature, we saw that yes, we could put in another 3 spoons of salt, but after that the solution is like, dude, I can't expand more than this, stop it, baba, right? At that point, you start seeing crystallization. You start seeing crystallization, because initially what happened was, see, you know this fact that is happening, you know this thing that is happening when you are putting a solid solute is added. Okay, let's write it down. Okay, so what is happening is, when a solid solute is added to a solvent, and the concentration is increased, we call it dissolution. So initially what was happening was, all the salt particles, they were like, yay, we are all in the water. So they were all clumping up together. Okay, so they were all together and dissolution was happening. They were helping they were helping the solution to increase the concentration. But at a certain point, they are like, too many people, I don't want to be here. I don't want to be here. Have you seen when there is an annual day school function? What happens in your annual day school function? If it is a class function, then the whole class comes together and they are all like, yay, let's have fun. But when it is a school function, what happens? Everybody forms, you all belong to the same school, no doubt about it. You all belong to the same school, definitely. But even then, what happens is, there are different groups that you start making, right? You are like, these are all, we all stay in the same society, so yay, we are huge friends. We all go to the same tuition, so we are all better friends. That happens, right? So people start forming groups and they dissociate from the annual function. Are you getting my point, what I'm trying to say? So here also what happened was, here initially you were putting in more salt, so everybody was happy that yay, we are forming a solution, we are increasing the concentration, great. But then when you kept adding more salt and you kept adding more salt, now the salt are like, too many salt particles, let's form a different group. And they started to come out of it in the crystallized form. Now they started getting crystallized and it was very unstable. So supersaturated solutions are usually very unstable and they can form crystals. Do I make sense, guys? Is this clear? Will you always and forever remember it? What is unsaturated? Not satisfied with biryani. Saturated, satisfied. Supersaturated, you were satisfied, but the greed from the eyes were not over. So now you want to eat more, you went unstable, that is supersaturated solution. Please tell me, easy peasy biryani tasty or la something which makes me understand that you have understood, everybody. Is this clear, guys? Is this clear? Roshan says clear. Okay. Yes, Swapna, Toma, everybody, is it clear, guys? Is it clear? Shall we move forward then? La, amazing. Thank you so much. So if you understood, promise me that you will share it with your friends also. Yeah. Unsaturated. So Rupesh, basically what happened is, and see, when I was saturated, I was satisfied. Like my stomach was like, dude, stop it. Yeah. If you eat more, there will be undigestion and loose motion will happen next time. Right. But my eyes said that biryani, bro, eat more. So I ate more. Now I became I became unstable. I was about to puke. That was supersaturated, right? When you heated the water a little bit and you started adding more and more amount of salt, but even after that you saw that at certain point it could not take in more amount of solute. And that's when what happened? Crystallization happened. The salt was like, too many salt particles. Let's get away from here, right? So that's what happened. Okay. Alright, thank you so much, FF Gamer. So glad that you could understand. Chalo. Now, what is the effect of temperature in solubility? Hey, obviously it will be there. We just saw that if you increase the temperature, the solubility did increase. But when? When I was adding salt, do you think it is an endothermic or an exothermic process? It's an endothermic process. You know why? Because remember, I heated it. from saturated to supersaturated, do you remember that I heated the solution? We heated the solution. We increased the temperature. That means that the container was absorbing the heat. And if a system absorbs the heat, what do we call it? Endothermic? Endothermic. So, yes. So, if a solution is endothermic and the dissolution process is endothermic, where you are adding more amount of solute and you are increasing the concentration, if it is endothermic, then what happens? As the temperature increases, solubility increases. Okay? Yes, what happens? Solubility increases with temperature increases. Okay? Solubility increases, temperature increases if the dissolution process is endothermic. But if the dissolution process is exothermic, then what happens is, then the solubility decreases with increase in temperature. Okay? No, actually, sorry. Let me just erase this. So don't read it as points, read it as a complete paragraph. I think then you will be able to understand. Is this clear, guys? Is this clear? If the solution is exothermic, if the dissolution process is exothermic, as in when you add it, it is releasing heat, then the solubility will decrease. Clear hai everybody? Yes, absolutely clear, crystal clear, guys. Crystal clear, guys. Is it biryani tasty, easy peasy? Yes, awesome. All right. Now then, moving on from here. What is the effect of pressure? Actually nothing. Okay. Actually nothing. When we talk about solids, we know that solids are normally highly incompressible, right? Like if I take this glass and if I try to compress it, do you think I'll be able to compress it? No. So solids and liquids are highly incompressible, and practically, pressure does not really change anything. So in this case, solubility does not change with effects of pressure. All right. Solubility does not change with effect of pressure. But now we come to solubility of a gas in a liquid. What do we learn? We learn solubility of a gas in a liquid. And when we're talking about gas in a liquid, what do you think? Gas in a liquid, obviously, pressure will change, right? Pressure will change because we know that gas is highly squashable. You can compress gas to a very high extent. So solubility of gases in liquid is greatly affected by pressure and temperature. That's exactly what I said, right? And the solubility of gases will increase with increase of pressure, and that's exactly what Henry said pretty much. Henry said that only. Henry said that the solubility of gases in liquids decrease when the temperature increases. Yes, because when dissolved, the gas molecules are present in liquid phase, and the process of dissolution can be considered similar to condensation, and heat is evolved in this process, right? Example of soda. Yes, we will talk about it. Right? So basically, that dissolved oxygen is there in the water, right? The aquatic animals, they breathe because there is dissolved oxygen in it, isn't it? Yes. So if you increase the temperature, don't we know that gases escape? That's why there are bubbles. Whenever you boil water, what happens? You see lots of bubbles. Why do you see bubbles? Because it's the gases that are trying to escape. So solubility obviously decreases when you increase the temperature. Making sense, everybody? Now, this explains Henry's law, okay? See, Henry says that in normal pressure, when the pressure is not so much, the solubility is only normal, okay? Now, when you apply a force and the pressure increases, when the pressure increases, solubility increases. What happens? When you increase the pressure, the solubility also increases. You can see now that more amount of gas molecules are present in the solution and less amount of gas molecules are present here. Righto? Absolutely. So moving on, now Henry has just wrote it in simple English statement. And that we have started to consider as Henry's law. Basically, he only said that the partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in solution. Alright, what he said is partial pressure of the gas. The partial pressure of the gas here. Partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution. The partial pressure of the gas in vapor phase, this is vapor phase gas, is equal to number of moles present in the solution. That's it. Which we can also write it as P is equal to KH chi. It's not X, it's chi. Yes, it's not X, it's chi. Now tell me something. Can I write this equation? Also like this P by chi is equal to KH? Can I write it like this? Can I write it like this, guys? Tell me yes or no. I can, right? Now, do you see that if pressure increases, number of moles decreases? But if this increases, then this will decrease. Why? Because see, inversely proportional. Inversely proportional. है ना? Right or wrong, guys? Do you see that this is inversely proportional, everybody? Exactly. So if you increase pressure, then what will happen? What will happen? Solubility increases. Solubility definitely increases. Yes? But what is happening? What is happening here? You get the point, right? Yes? You get the point, everybody? Understood? Understood, everyone? Understood, guys? Yes? Okay, very nice. Now, different gases, right? Different gases, obviously, the pressure and the chi, yes, it will be different. The mole fraction of the gas will be different, right? Yes. So, different gases have different Henry's constant. This KH, this is the Henry's constant, okay? This is Henry's constant. So, different gases have different KH values at the same temperature. And that means that KH is actually a function of the nature of the gas. KH will depend on the nature of the gas. Am I clear, guys? Am I clear? So with this note, we are actually done with Henry's law. Was Henry's law too difficult? It wasn't. It wasn't. It wasn't, right? Am I right or wrong? You can also do this here. You can also do this here, that the slope, if you draw a graph here like this, P and chi, then the slope here will give you KH. Graphical representation of Henry's law is like this, okay? Graphical representation. Graphical representation is like this. Easy peasy biryani tasty, absolutely. All you have to remember is P is equal to KH chi. Alright? P is equal to KH chi. Alright. So moving on from here then, what are the applications of Henry's law? Where have you seen Henry's law? You have seen that in the soda water bottles, you know that carbon dioxide is packed under really high pressure. And the moment you unseal the bottle, it all comes out. Right? Yes? What are you doing? You are decreasing the pressure at that time. And that is why carbon dioxide escapes, because now the solubility is not going to be that great. The solubility was great when the pressure was high. Right? Also, in case of deep sea divers, yeah, deep sea divers, I think you remember this, you know, in class 8, we read about force and pressure. That's when we remembered that amount of force or amount of the pressure that sea can exert on you. When you're trying to swim, it does happen that your ears feel blocked and you get to hear the sound as something like this kind of sound that you get to hear, right? You must have heard that. How many of you know swimming? If you know swimming, then you must have definitely tried this, isn't it? So basically, when you go down under the water, what happens is all the top layers of the water, they apply pressure on you. They apply pressure on you, right? Yes. Now imagine you are going at the bottom of the sea, bro. And can you even imagine the amount of water that is present in the sea? That much water is exerting pressure on you. So if you do not wear the right kind of suit, you are actually going to go. The sea water can literally squash you. I swear to God. Seriously. And that is why it is very necessary. You must have seen that scuba divers, they never go without their suit, right? Yes. Now what happens is nitrogen is actually more soluble than helium in our blood, right? And in the deep sea, the pressure is way higher than the surface of the water. Okay. All right. Yes. So when the divers, they try to rapidly come towards the surface of the water, no, the pressure decreases. And whatever dissolved nitrogen comes back from the blood, it makes bubbles in the veins. And that's why they have to use oxygen that is diluted with helium. It's a crazy, crazy dangerous thing that the scuba divers do. I am very scared of water, to be very honest. Like really, really scared of water. I can only go till like knee-high level of water and that's it, and I come back running. But yeah, some people actually take this risk just to see how the underwater looks so beautiful, right? Yeah. So did you understand the application of Henry's law? Do we understand this, everybody? Is this clear, guys? Yeah. Shall we move on then? Now we have a question here. So tell me, the molarity of a solution that is obtained by mixing 750 ml of 0.5 molar HCl with 250 ml of 2 molar HCl will be. Oh my God, this is so simple. Okay. What are we asked to find out? We are asked to find out molarity. So let's say M final is equal to basically M1 V1 plus M2 V2 divided by V1 plus V2. That's all that we have to do. So what will we do? 0.5 into what? 750. 0.5 into 750 plus what is M2? M2 is 2 into 250. So 2 into 250 divided by 750 plus 250. Come on, do this and tell me, guys. What do you think is the answer? What do you think is the answer? And guess what? When did it come? I think this had come in JEE mains. I think this has come in one of the JEE mains. You are not even kidding. What's the answer, guys? Please tell me. Come on. Chalo, till then I will also calculate. It's coming up to be 0.875. Is this clear? Oh, option A is the correct answer. Option A is the correct answer. Vamsi, no, it was option A. That's correct, bacha. Option A is correct. Chalo, next question then. The oxygen dissolved in water exerts a partial pressure of 20 kPa. Okay. In the vapor above water, the molar solubility of oxygen in water is dash into 10 to the power minus 5 mole per dmq. Round off to the nearest integer. Henry's law is given to you and density of water with... Okay. Alright. Chalo. So what is given to us? Let's write it down. Given to us is that What am I writing? What is given to us? Given is P is equal to partial pressure, right? P is equal to 20 kPa. Alright, everybody? Yeah, no problem. It's okay. And Henry's law constant is given to us, that is 8.0 into 10 to the power 4 kPa. Right? Now, what is the formula that we know? Formula we know is P is equal to KH chi. Yes? So, chi is equal to P by KH. That means that 20, I can write this as 10 to the power 3 and 8.0 into 10 to the power 4 into 10 to the power 3. Can I write it like this? I can. So 10 to the power 3, 10 to the power 3 get cancelled. 4 2s are 8, 4 5s are 20. Now 2 2s are 4, then 1 10 2.5. So this I can write it as 10 to the power 4 to 2.5. That means 25 into 10 to the power minus 5. The answer is 25, guys. Answer is 25. Done, guys. Is this understood? Is this understood? Very simple, very easy. You just had to, from kPa, you just have changed it a little bit and you have just put 10 to the power 3. Okay, got it? Easy peasy. Biryani tasty. Clear everyone. Tell me. so that we can move on. Here is the solution if you're not able to see. All right, in that case, I think we are done. Oh, I was supposed to write the solution here, but I have written it there anyway. So with this note, guys, we have come to the end of the session, and don't forget to like and share to Vedantu JEE English channel. You know that we are catering to JEE as well as MSET, as well as BITSET, as well as VIT EEE, which we will from this year. Pakka promise. So do share it with your friends. Thank you so much for watching this session. And last but not the least, if you want to stay connected with me, then Nabamita_Nobita, this is my Instagram account. I will see you, everybody. And do share it with your friends so that, you know, more number of more number of students gets to know about this Vedantu JEE English channel. All right, with this note, Tara, bye-bye. I will see you tomorrow with mole concept from class 11. Don't forget to also share it with your juniors. Tara, bye-bye. See ya.